Okay, so this was back in March 21 where I first dabbled with the Postgres MVCC architecture, and I noticed that there's a concept called vacuum. And before that, I was completely unaware that what the hell is vacuum. And after that, the journey started with Postgres and things, and I'm here to talk about that. All right, what is vacuum? Simply said, vacuum gets you your storage back, okay, and it also makes you plan your queries very effectively, like correctly, I'll say. And let's do that. Why is vacuum? So I tried to make a little pun there. If anyone has watched Infinity War, why is Gamora, why is vacuum, that sort of thing. All right. Uh, so there are mainly four uses of vacuum. Get you your space back, and second is to update data statistics used by the Postgres query planner, and the third is to update the visibility map where it can speed up your index only scans. All right, and the fourth most, which is very important, is the transaction ID wraparound thing, where if you don't vacuum your tables correctly or regularly, bad things can happen. The ghost rows, like the deleted rows, can come back if the transaction IDs overflows by 2 billion mark, and or the updates which you did to the rows, they get reverted. Okay, that's bad thing can happen. Let's talk about maybe different types of vacuuming. There isn't much to talk about. There are two types of vacuum: the standard vacuum and the vacuum full. Vacuum full, a disclaimer: vacuum full is very bad in some cases. All right. Okay. Looks like we're talking about the bad thing first. Vacuum full takes excess exclusive lock. So what does that mean? When it takes that lock, you cannot do any update, insert, or delete operations to the table. Essentially, what it does is vacuum full will take your rows which are not yet deleted, or those active rows, and it will copy over to a new disk space, right? And that takes time as well. It might bring your DB down, downtime sort of thing. Okay. And while this is happening, you need to have that storage space as well, like actually equal to the storage, the size of your table. Okay, and that's needed during the transfer. But after that is finished, it automatically returns, like immediately returns the freed up storage space, the deleted rows and the old versions, all tuples of the rows, back to the OS, which is good enough. Like if you had a very large update thing happen in your table, then you might want to run the vacuum full on non-business hours. So that's something good. And well, of course, all of this is available in the PG start progress cluster table. And if something is going on, like vacuum full is going on, you can check that table and see what's the progress and things. All right, let's move on to the standard vacuum. Okay. Can use insert, update, delete while this is running, the standard vacuum, but you cannot alter the table. And I'll tell you an interesting story about it later on. And again, generally much better than vacuum full. An interesting thing about standard vacuum is that it doesn't return the space, the freed up space, to the OS immediately. It only does that when the whole Postgres page is marked to be freed. Then it will return the space to the OS. But standard vacuum, what it will do is it will mark the rows or the deleted rows to be free for reuse. And as I talked about in vacuum full, the reporting happened in pgstart progress cluster. But in this thing, standard vacuum reporting happens in pgstart progress vacuum. Okay, cool. Let's talk about that interesting incident I encountered when I was working on this. So we can't use alter command in Postgres like when the standard vacuum is running, right? And we had an auto vacuum set up when I used to work at a logistics company, and we didn't know the vacuum was running, and we were doing a late night deployment. Okay, and it had a migration file which contained the alter command. That took down our DB for 3 minutes, due to which it cascaded into other services failure, led to data corruption in other tables because the microservices just cascaded back and forth, and there was no circuit breaker which could prevent these things. It took a lot of time to get that data back to its pure state, pristine state, and that's mainly it.